We're supposed to graph y equals sine x minus pi over 3. Sophie, what would you write above this? Y equals
a sine b parentheses x minus c parentheses.
Good. And Manny, what is your a value? A value is 1. Your b value? Yep. And your c value? I'm sorry? Partner B tell partner A, which direction am I going? Based off your C value? Maria Bellinwich, what direction are we going?
Right.
She says right. Thumbs up, thumbs down. That is correct. Your C value is greater than 0, you're going to the right. And remember the silly phrase, add to go west or left. So we don't have adding, so we do the opposite, which is to the right. Alright, let's use the period now. If I just put in your b value of 1, your period is just going to be what? Okay. This here told me where to start and where to end, right? We normally did something like this. I would normally put this over here, right? But look at the length. The distance was between 0 and 2 pi normally, yes? But now we're going where? It's going to be shifted to the right. So all this green box told me was the distance between my two fingers. Now this one is actually going to tell me where it is. Okay? So you're going to put your function. Everyone say to the right.
To the right.
Sounds like we're doing a dance move, but everything to the right of the trig function, to the right of sine, you're going to put here. It does not matter if you have like something outside of the parentheses or just a bunch of stuff in there. Take all of it, everything to the right, and put it between 0 and 2 pi. Let's do that together. X minus pi over 3. Here we're solving a compound inequality. There are two ways of solving compound inequalities back in Algebra 2. You could have separated them into two. Here's my first one. And here's my second one. Another methodology of solving for x is just kind of doing it together. So if I add pi over 3 into the middle, what do I have to do to both sides? Add pi over 3. Class 0 plus pi over 3. Pi over 3. I have less than or equals to. Here, negative and positive of the same number is equal to 0. They cancel and equal 0. I'm left with x. I can't add these two fractions together. I'm going to need equivalent fractions. Class, how do you make 2 pi a fraction? I'm going to have to multiply by 3 over 3. 2 times 3 will give me what?
6.
So 6 pi over 3 plus 1 pi over 3 gives me what? 7 pi over 3. Now, the next step, partner A tell partner B, what's the next step? Juan, what was our next steps?
To get to 4 equal points.
We would normally have 4 equal intervals or 5 points. So this is what we would normally do. 1, 2, 3, 4, 5. Right? The period would normally start at 0 and 2 pi, but it's been shifted where? To the right. So I'm going to have to add another point. And here are my 5 x-intercepts. 1, 2, 3, 4, 5. And there's my 4 intervals. 1, 2, 3, 4. Hopefully I can make this super obvious. The numbers I'm going to put on these axes now are right here. This idea of 0 to pi over 3, it's been shifted over that green amount. So I'm going to start at pi over 3. I'm going to have 7 pi over 3. Alright, let's do some processing. Partner A, you got to review all the old stuff. Step 0, A, B, C, D, and then period in the green box. Partner B, I want you to explain the new and then our new graph. I want your 5 x values. You guys will do that together. Take 60 seconds. Ready, set, go. Juan. 1 plus 7.
8.
8 divided by 2.
8 divided by 2, 4.
4 pi over 3. Raise your hand if you got that one. Okay. Juan. 1 plus 4.
5.
5 divided by 2.
5 divided by 2. This 2. 0.25.
Okay, so we normally wouldn't do this, right? This looks kind of weird. Let me show you why. You have a decimal and a fraction together. But we've always been working in what? Fraction. So there's 2 ways of getting this value. Here's the first way. Class, if you double both the numerator and denominator, multiply by 2 over 2, you get what? 5 pi over 6. Raise your hand if you got that. Another way of getting 5 pi over 6 is just doubling all of these. So I get 2 pi over 6. Class, what does this one become?
8 pi over 6.
This one.
14 pi over 6.
And then what are they counting by? 2, 5, 8, 11 pi over 6. So let me circle the ones that are simplified. 1 pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6, and 7 pi over 3. These 2 steps alone are probably the most difficult ones of all of it. Just the fractions. Okay. Now we're going to find step 3. We have our x values. And now we're going to do step 4, which is to what? Evaluate it using our table of values. So my x values are pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6, 7 pi over 3. Now these fractions look daunting. But just like Star Wars, there is a new hope. The hope is that eventually we'll get to the quadrantal angles. Does that make sense? Alright. Put your finger at x on the original equation. Class, what do we need to do? We're going to subtract all the values by pi over 3. So all of these values, right? Pi over 3 minus pi over 3. Okay. Pi over 3 is like negative 2 pi over 6. Would you agree?
Yes.
So 5 minus 2 is, and 3 pi over 6 is. Reduce it. 1/2 pi over 2. Do you see the new hope? 4 pi over 3, 4 minus 1. 3 pi over 3, which is just pi. 11 minus 2. 9, and 9 pi over 6 is 3 pi over 2. Do you guys see what's happening? What's happening? Stuff. It's going back to the quadrantal angles. 7 minus 1. And 6 pi over 3 is 2 pi. Right? Are you guys following along? Okay. We wrote down our 5x values. We subtracted pi over 3. Now what do we do? In the Star Wars saga, there was many traps. Don't say anything. Don't say anything. Tell your partner Darth Vader's trap. Raise your hand if you see the trap. Okay. About a third of the students raise your hands, right? And a third of the students made this mistake on last year's test over many, many, many years. For those who raise your hand, the numbers I wrote down represent what? Cosine. Not sine. If you forget, just draw yourself the quadrantal angles and label the order pair. Class, what's the order pair?
1, 0.
Huh? 1, 0. X, Y, cosine, sine. Sine at 0 is 0. So this row that I wrote, I purposely did that to show you that a lot of students will make that mistake right there. So class, what's the number? 0, 1, 0, negative 1, 0. We made it out of the Death Star. I'm just going to arbitrarily pick any boxes and just write 1, and then 3 boxes down, negative 1. Pi over 3, 0. Yahweh. 5 pi over 6, 1. 4 pi over 3, 0. 11 pi over 6, negative 1. And 7 pi over 3, 0. Smooth curves. Let's review what we've done so far. We identified the letters. Class, what does the A value represent? Amplitude. Look. Remember, your amplitude is either from here to here or from the midline to the minimum. The B value helps you find your period. Class, what was the old period? Let me show you where this is. The old period is still in your graph. It's the distance between pi over 3 and 7 pi over 3. Class, what's 7 minus 1? And 6 pi over 3 is? 2 pi. Does that make sense? It's telling you the total distance. The new part is there's a shift. It's being moved over. This whole graph is just being shifted over pi over 3. And then we just evaluate it using our table of values.